Good morning, everyone. Welcome to CABAA's first safety committee webinar of 2025. My name is Cole Greaves. I am a active CABAA safety committee member. And today I'd like to introduce us by our title of Protecting Yourself Against Thermal Runaway. Today's presenter is Brian, and Brian has served as the Vice President of Operations for Aircare International for the last 13 years. He's a retired firefighter and paramedic. Brian focuses on the program and instructor development along with product design for Aircare. Prior to his operations role, Brian was a line emergency procedures instructor for Aircare FACS training over a decade, specializing in medical and fire education. Current projects include development of the next generation Aircare Fire Sock, a thermal runaway protection tool for business aviation. A Pacific Northwest native, Brian works in the company HQ located in Tacoma, Washington. And we are excited to hear more about the important topic of in-flight thermal runaway in the cabin. And let's turn it over to Brian. Before we get started here, if anyone has any questions, please post that in the chat function down below. And then at the end, we will do a Q&A to wrap everything up and answer any of those questions. Brian, go ahead, take it away.
Sounds good. Thanks for the intro. So this is an interesting way for me to do this. I'm normally out in the field doing this. It's been like COVID time since I've done it this way, and I can't see everybody. So I don't like that part of it, but hopefully we'll get some interaction later with some Q&A. Excuse me. You have to forgive me. I'm just getting over pneumonia, and I'm starting to get back to normal, but almost. So I apologize a little bit. So what we're going to talk about today, just kind of one of my passions, is about just firefighting in general. I'll kind of give you a little background on that. And the goal of this for me is to get everybody a little more educated on what thermal runaway is. It's different than other types of firefighting. So we'll talk about that. I hope I generate some questions. I also hope to, by the end of this, I want to spur you on to make a plan to deal with this. Like I said, it's different than the microwave catching on fire with the toilet motor. So we'll get you up to speed on that. Hopefully, generate some questions, and we'll get going. So, in addition to that little intro about me, thanks very much for that. I've been with Aircare. I did the math the other day. I think almost 22 years now. And before that, I was a firefighter. As he said, I worked on a crash fire rescue team at an airport, but mainly I was a structural firefighter. Interestingly enough, I will date myself a little bit here. The airport firefighting I did were back in the days when we foamed runways. And the last aircraft accident I was on before I left was a King Air that had landing gear issues, and we foamed the runway for the guy. He came in to land that thing, and he flew right over the top of our foam and touched it down beautifully past the foam, and it was all for naught, and it was all fine. But that's the kind of the last airport firefighting I did. On the structural firefighting side, just a little anecdote about that. Going inside of burning buildings was one of my favorite things I've ever had the opportunity to do. Go in and do structural firefighting has always been a fascinating and exciting thing for me. So it's one of my favorite places to be, is inside of a burning building. That being said, I can't think of a place that I would rather not be than on your aircraft at altitude on fire. Think about that for a minute. If your house catches on fire, kitchen fire, let's say, cooking some lasagna and the stove catches on fire, oven catches on fire, you try to put it out, you do some water maybe, or you have an extinguisher, or you put a wet blanket on it, something like that, and it doesn't work, and the fire starts getting big. What do? Well, eventually you will make the decision, hopefully you've already called for the fire department, you will just leave the darn building. You will get out and you will be fine. Maybe not the house, but you will be fine. You do not have that option on an aircraft. You're at 35,000 feet and that round metal sealed tube catches on fire, you've got yourself a problem. So what I want us to think about during this is, I will leave you with this, or start with this and I'll end with it as well, is I want you to be aggressive firefighters. when it comes to your aircraft. These are not the kind of problems you go, I think it's probably going to be okay. We'll just let go, and I don't think it's going to get to be a big problem. You can't do that. So I teach this to all the pilots that we see, all the flight attendants that we see. I want you to be aggressive when it comes to firefighting, and that comes with a plan. So we'll talk more about that as well. So anyway, that's my background in this. I'm very passionate about firefighting, especially aboard aircraft. I've been doing this for a long time. I hear the stories. And I would imagine most of you don't have too many stories about ditching an aircraft in the ocean. I would also imagine that most of you do have a story about some kind of smoke or fire emergency on an aircraft. It's just one of the more common emergencies. And sometimes they're not so bad. Sometimes they're catastrophic. So that's what I want to get to start out with this. And then we'll kind of focus now on some of the thermal runaway stuff. So first of all, kind of some of the boring stuff here. Does it happen? It does. I just grabbed a couple of quick stats just to talk about this. There were, according to the FAA, in 24, there were 84 incidents in all of commercial and private aviation, excuse me, with some kind of a thermal runaway. Some pretty serious, most not. And we'll talk about why that is too. Just a couple of these. In February, they had a flight from Kona to Denver. They spilled water on somebody's battery pack that used to charge their phone or the computer, and that sent it into thermal runaway. Interesting, right? Just dumping water on that threw it into thermal runaway. They ended up placing it in a containment bag. There was no further issue. Kind of stayed like it was, and they finished the rest of the flight. Interesting. In November, they had one, San Francisco to Dallas. They had smoke in the lab. They entered the lab and they found somebody with their laptop in the lab, and it was overheating. It was smoking at that point. So I think they went in there to kind of hide because they were embarrassed that their laptop was smoking. I can't imagine taking it in there for another reason. Anyway, so they ended up doing the same thing. They grabbed it immediately, put it in a containment bag, and the flight continued. It didn't tell me if it continued in thermal runaway. It would have been interesting to know, but it sounded like it wasn't that big of a deal. And then just the third one I grabbed, it was during a landing from JFK to LAX, and a battery pack entered the runaway. They don't know why, and I'll talk about some of those reasons in a minute. Flight attendants fought the fire, so this was a decent enough fire they had to fight. Talk about that. And then they got on the ground. This was during landing. Ground personnel then took it from there, threw it in a containment bag, took it off the aircraft. One of the passengers did suffer some minor burns, but they didn't need to evacuate the aircraft. So that's the deal. These things do happen. They can be very innocuous. One of the main types I've been reading lately is about the e-cigarettes. E-cigarettes they're really cheaply made, and those little batteries will blow up, often in people's pockets, by the way, excuse me, causing a little bit of injury there. But I'm telling you right now, an e-cigarette is not going to take your aircraft out of the sky. Do you need to deal with it? Sure. But some of the bigger units and some of the bigger battery packs you have can cause some pretty significant problems and the ifs there are if it gets bad, if it goes into full runaway, where is it located? What's around it? Is this your electronic flight bag on the flight deck that starts causing problems up there? Is it something that's in the baggage compartment in the rear? Who knows, right? It depends on where it is. So we can talk about some of those things. And like I said, excuse me, we'll answer some questions on that. So I'm going to do a couple of little boring things first, just because I want you to understand what it takes to make fire. And then that'll lead us into kind of why this is different, why the thermal runaway is different. In firefighting, when I left it, was just changing because I left right when lithium was coming on, especially in cars. And it's a whole different ballgame now with how you do that. So let's talk about what it takes to make fire. So there's the definition. It's a rapid, persistent chemical change causing the release of light, heat, and accompanied by flame. Sure. Well, most of you know or have been taught that it takes three things to make fire. oxygen, heat, and fuel. Well, it's not overly accurate. It really takes 4 things to make fire. So it's not a fire triangle, if you will. Technically, it's a fire tetrahedron, fancy term for a 3-dimensional triangle, right? Because it takes 4 things to make fire. It's oxygen, heat, and fuel, but it's also this chemical or chain reaction that occurs between those products that causes fire. Why is that important? Why is advanced fire science important? Because it's where you attack the fire that is important. And it's different when it comes to TR on this. So your job, no matter the fire, is to break that chain. You can do it several ways, but all you do is you take the oxygen away, it's going to collapse. You take the heat away, it's going to stop, right? Take the fuel source away, you get the picture. One of your main firefighting weapons in aviation, which is different from everywhere else, folks, you guys are one of the few left that have access to what I feel is one of the best firefighting tools on the planet, and that's halon and some of the halon derivatives that you have now. Halon is an unbelievably effective firefighting agent. Well, 2 caveats to that. One is we never used it in the fire service. We never had halon on our fire engines because it was pretty useless in structural firefighting or outside wildland fires, things like that, because halon's a gas. In an enclosed environment, I've never seen anything better to fight fire. My colleagues always said I should be a halon salesman because I believe in this stuff so much. Well, second point there, unfortunately, halon, virtually useless when it comes to thermal runaway. Now, not completely useless. It's still in the protocol to use. I'll explain all that, talk a little bit about that, but mainly halon is just not going to be your buddy on this one. So we'll talk about how to do that. I want to go into a little bit about what happens and why these things are a big deal. So first of all, think about this. Even on your 13, 19 seat aircraft, whatever you guys are flying out there, how many lithium batteries are on your aircraft when you take off? And you move that to a commercial airplane with a couple hundred people on there, you've got hundreds of devices, right? I bet you have 30 or 40 at any given time, some little ones, some big ones. There's a lot of potential. And that's why we see that every few days, essentially, is what happens. Every few days, there's a lithium fire incident on an aircraft. If you take it into homes and things like that, it happens multiple times a day, where things like scooters and electric bikes and all these other things start catching on fire. But on the aircraft, what are the things that you're worried about? It's certainly mobile phones, tablets, laptops, and kind of one of the other hidden ones that I'll talk about in a second too. There is a limit to how much you're supposed to carry, 100 watt hours of battery per person on an aircraft, but that's a lot of energy. Your laptop, depending on the type of laptop you have, 30 to 50 watt hours is a laptop. Anyway, phones are less. I want to show you a little bit about what thermal runaway does. This is just one that's been set in motion to vent, and they put some heat to it, and you see what happens. It starts to smoke. I kind of cut short this video a little bit, so it's already started smoking, right? That's one of the batteries venting. The battery vents, and it starts to heat up the battery next to it. You see the next battery vents, and this smoke comes out. Excuse me. The smoke comes out, and more smoke as the batteries continue to vent along the pack. Well, eventually, it still continues to build up heat, and the batteries are going to keep doing what they're doing because nobody's stopping this process, right? Very difficult to stop, by the way. And now, eventually, what's going to happen is it's going to get hot enough in there, and you may get a fire. So there's the probably the last of the batteries venting, and now it has lit the rest of the stuff on fire. This is the plastics and everything else. If it's sitting on a table, if it's in somebody's briefcase. This is kind of the sequence of events that you're going to look at. How do you deal with that, right? How are we going to deal with that? We'll talk about that. So what thermal runaway is itself, it's a very violent exothermic reaction. It's these there's a lot of energy stored in these batteries. And when they, for a plethora of reasons, which we'll talk about as well, when they fail, they expand rapidly. They get hot, and we're talking temperatures here that are different from your normal fire and a normal campfire, something like that, that temperatures I'll tell you about. The other thing is, why do they do this? And there's really no rhyme or reason. There are some things, if the battery's damaged, you've heard the thing where it gets caught between a seat and it breaks the battery, and that can certainly do it. One of the misnomers about this is that the unit has to be plugged in to go into thermal runaway. That is absolutely not true. They will go into for lots of reasons, often the manufacturing process, their defect. Actually, my wife just got a new iPhone, and day one, it failed. I haven't seen an iPhone do that in a long time, but day one it failed. It never did blow up, but it got super hot where you couldn't even touch it. So turned it off and took it back. So it happens. Manufacturing, who knows? So why? Excuse me. Why are these more dangerous? A couple of things. Temperature, like I'm talking about a little bit here, is part of it. The other is what happens when these things expand. So it's the type of gases that are emitted, and I'll show you a slide on a second here, and then these high temperatures that light things around it on fire. So that's why I want you to be able to contain and or extinguish these things as quickly as possible. You may not be able to prevent this from happening. It's not like a fire that you can see, that you can hit with the halon and it's done. It's not like that. There's an exothermic reaction that occurs that I'm not saying you can't stop. We'll talk about ways to do that, but it's very difficult to stop. So there's the setup for what the heck is happening in these batteries. So as I was just kind of mentioning, some things like mechanical damage, you drop the thing, it's an older battery, gets a lot of abuse, that can start to cause it. And some ways to notice, you'll notice that slowly over time, they can begin to bulge. They can make noise. It's not always just smoke and fire right away that you're going to see. You're going to often have a warning that this is happening. Sometimes you'll hear or see the gas venting itself, which will most likely be in the form of smoke, but there's also gas in there. And then of course it just gets super hot. So let's talk for a minute about what the gases are that are produced from these exothermic reactions. Variety of gases. So there's a list there, and I'll talk about some of these that are considered dangerous, and then there are some toxic. So the dangerous gases, carbon monoxide, hydrogen, and CO2. Okay, everybody's heard about those gases. Those are dangerous, but it also, depending on the battery type and what you've got going in there, can release a series of toxic gases: hydrogen fluoride, hydrogen chloride, hydrogen cyanide, yes, hydrogen cyanide, the stuff that you think that is, sulfur dioxide, and of course methane. Yeah, these are some bad gases. The hydrogen, I think it's, well, there's a couple of those that were used as nerve agents in World War I. They can be bad. Now, that sounds horrible, like everybody's going to die if a battery goes off. It's not like that. These are bad gases. I don't want to be in an enclosed area with them for a long period of time. Your airplane, because of the nature of the airflow, it's not the same as an enclosed room. If you were in just a small enclosed room, like say the lab, but there was no airflow in the lab, and you lit off a full laptop, I'd be a little worried about what you were inhaling there. Some of that stuff is pretty nasty stuff. Excuse me. So that's a concern. It's a concern. It's not, if I'm being honest, it's not my main concern. Uh, there are some dangers with these types of gases, but mainly there's another one. So I'll take you to another slide in a second. But from that list of gases, I want you all to think about which one you think is the most dangerous of those gases, and I'll reveal it here in just a second. Uh, we've got carbon monoxide, that's bad stuff, hydrogen, I don't know, CO2, and then of course the toxic ones. Which of those do you think is the most serious? Well, I will show you. I'm going to show you just a little tiny video clip here, a few seconds long. This is a fire testing facility that tried to make this worst case scenario. So please understand, this is worst case scenario. And they took some lithium batteries, they off-gassed them in an enclosed room, and they lit them on fire just to see what would happen. And it's impressive. This was in a garage. They put the gases out. As soon as the gases were filling the room, they lit them on fire. So enclosed, single car garage. And that's the ultimate, right? That's an explosion. That's a darn big explosion in an enclosed environment from a hefty set of lithium batteries that might be in your garage for your lawnmower, let's say. So decent size, a couple hundred watt hours of battery. So it can. Now that's excuse me, that's the ultimate. I've never seen that happen. I'm going to show you a couple of small video clips here where we did some testing. So we developed over the last several years some containment products, and I've just been doing this for years, trying to figure out what happens with this. I'm on the UL testing board as well. There's some tests out there from United Laboratories that we've put together for these things to show different products and how they work and how they don't work as well. Also, I spent a lot of time with the FAA on this. They have a kind of a set of guidelines that are slowly changing over time. We all know how the FAA works. They're a great regulatory agency, but they're sometimes slow to react. So I'm going to talk about toward the end of this what the recommendations are, and then we'll talk about some real life stuff too. But just real quick here, I want to show you just a couple of short videos on what happens when batteries are induced to go into thermal runaway in certain applications. So on this first one, I just put it in a plastic box. I wanted to see what it would do when containment, yes, but no extinguishing whatsoever. This is quite a ways into it, but if you notice, the temperature is only 300 and some degrees, and it begins to vent. Now, I know you can see through the smoke, now the temperature is over 1,000 degrees. When it goes, it goes. And that's the extent of it. This was a four cylinder. It's 1,500, I think, degrees on there now. And it's just a decent amount of smoke. Is something you have to deal with? Sure it is. Is it bad smoke? Yes. It's not good stuff to breathe. But that was the extent of that one. I want to show you one that's a little different, uncontained on this one. So this is only 4 cells. When then they're just placed in a plastic box, kind of like an enclosure for a battery pack or a computer, when this one goes off. So I don't know if you can see very easily, but when the first cell goes, it vents, and it's up to 1,000, 1,200, or 1,200 degrees. Really quick that it does that. But then it kind of tends to calm down. Sorry, my voice is in the background of that. It calms down a little bit. The temperature is just under 1,200 degrees, but it looks like, hey, not so bad. It seems to have calmed down. The battery vented. There's a little smoke coming out, but it doesn't look too bad. As it goes on, it's heating up the batteries next to it. Thermocouple temperature. So yeah, I'm sorry, I'm kind of narrating over that. So the thermocouple that we have attached to that is still hanging out about 1,100 degrees, but it doesn't appear to be that bad. The other cells have not gone yet, and it depends on how those cells react, and they're different every time. Sometimes they vent like that first one did, a little bit of sparking, a little bit of smoke, and you're done. Now the temperature's going down. Look at that. Now we're under 1,000. We're just 950 or so. Maybe this is over. Maybe this thing is just going to kind of go out on its own. And then you just never know, because when it decides to go, it's going to go. So there's an explosion. Now that creates all kinds of other issues, right? So the unknown part of this, the unknown with what's going to happen, is why you have to be kind of light on your feet when you're dealing with these things. We're going to talk about how to fight the fire now. And before I do that, I want to tell you about the gases a little bit. I'll kind of end that part on the gases, the dangerous gases, yes, the toxic gases, yes. The most dangerous of all, and what you saw in that garage explosion and what you saw with that last little video with the little tiny battery pack going, that's one gas. That's one main gas. Now there's other gas, but there's one main gas, hydrogen. Remember the Hindenburg? That's what this thing is producing. That's the explosive risk. It doesn't happen every time. You saw from the box, the yellow box, it vented, and the smoke came out, and that was fine. On the other one, the conditions were right. The hydrogen ignited, and hydrogen is very explosive. I would dare say that if that laptop was in the lab by itself, let's say, right? It's in the lab for some reason, and it vents and explodes, it'll blow the door off the lab. I really think it would. I've not tried it for real, but there's enough explosive risk in that much space to do it. Will it do it on the airplane? If like in the cabin of a cabin class aircraft? Never seen it. I've never seen it truly do that, where it builds up and explodes that way. The conditions aren't right for that because of the airflow, because you're changing the air in the cabin constantly. It's not ripe for that. Doesn't mean it's not dangerous. It's going to go, and you saw that other one where it just starts to fire, but it's not going to be as explosive, most likely. But I want you to be aware of it, because it depends. If it's in an enclosed environment, it can certainly do that. So I got to keep going here. So let's talk about how to fight the fire. I mentioned halon a little bit. Halon's a lovely extinguisher, really great for an open flame. It will put a flame out rapidly. I used to be able to do a test in class when I would teach firefighting for real, where we could use halon in training, so I could demonstrate. And the test that I used to do, a silly little test, but I would light a candle and I would take it and put it in the back of the classroom, just a normal candle. I'd stand at the front of the room. I'd take a halon extinguisher and I would deploy it for like a second. And I would just kind of aiming it up. And I would wait. And at about 7, 8, 9 seconds, the candle would extinguish. Halon just flies over there, fills the space a little bit, and it puts the fire out. Amazing stuff. It's really amazing stuff. Not in this situation, because it doesn't do anything for thermal runaway. Thermal runaway is that exothermic process, right? It's not a paper fire. It's not a seat fire where you can knock it down. How do you do it? Best way is through the temperature part of this. It's to attack it on the temperature. During the testing, and I think the last test I did was test 44. I've done a whole bunch of tests with these different batteries and different configurations. And what I found is that around 300 to 400 degrees Fahrenheit is when the process will begin. Now, how you get to that temperature, who knows, right? The batteries do their thing. But once it goes into thermal runaway, it jumps up to over 1,000 degrees, and the highest readings I've had was 2,200 degrees Fahrenheit. The temperatures are immense, and they will eat through things and melt things and light things on fire that shouldn't be lit on fire. So what your job is to attempt to hit the heat side of this and cool it. How do you do that? Water, right? Water's a great one. They also have aqueous extinguishers, which is just a fancy term. All it is, it's chemically altered water. It's kind of fancy water, and it works. I got to tell you, I've got one of them here. There's several different kinds. This is one. It's just I think, yeah, this one's Firebane, but it looks like it's like dark water, but it simply puts out fire better than water. It takes the temperature and just makes it take a nosedive real quickly. So some kind of an aqueous extinguisher, water, anything like that will start to cool it. But think about this. If there's a laptop on fire and you dump some water on it, this little guy was like a little shampoo bottle of it, right? You may take your normal water bottle, your plastic water bottle, and squeeze some water on it. Great, that's fine. You're getting it out there. If that laptop is sitting on the table and it's closed and it's venting and you dump water on it, is that getting where it needs to be? Is that really doing a lot of cooling? It can be a challenge. If the laptop is open and you can get it there, sometimes you can get it, but it's not always easy to get the extinguishing agent to the heat source. It just can be a challenge. So there's a several step process that they want you to go through to do this. And I'll talk about the actual FAA approved process, and I'll talk about some real life stuff too. So it's knocking it down. And the other part of it is containing it. Containing it, by the way, doesn't stop the process. Containing it does just that. And those, just like you saw, the smoke coming out, that's going to continue to happen. You have to expect that if you put this in a containment device. It will protect the rest of the aircraft. If this thing is just sitting in the lab or sitting on the floor or sitting under a seat and it goes off, it's going to light other things on fire. Yes, everything in the aircraft is flame resistant, but I'm telling you, not to 1500 degrees. It's going to go. It's going to light on fire, and it can be a pretty tough fire to fight. You can do it. You've got the tools to do it, but understand it's going to be tough. You want to be able to cool it for at least 15 minutes. Once the fire or once the thermal runaway stops, it doesn't just dive down temperature. It gets below thermal runaway temperatures, but it still stays pretty hot. The tests I was conducting, 20 minutes later, it was still 400 degrees glowing in there, excuse me, after the batteries had gone. So it stays hot. So a lot of cooling, a lot of dumping of water on that or in the containment device to keep that going. Speaking of containment devices, I just want to show a couple, and just so you guys know what's out there. There are a bunch of containment. I don't really, whatever you have is great. This is just one of the ones that we have. It's just full of fireproof material. It's just a sleeve that folds over, that seals everything in, and has built-in vents because you want to let it vent. What I don't want you to do is seal something up and so it's airtight, because you're just creating a bomb. I was talking to the UL in one of our UL meetings, and they said you need to be able to prevent this from happening and complete containment so nothing escapes. Excuse me. Possible to do. I can do it. The box weighs about 50 pounds, and it will lock in place, because if you do a lighter weight one, it's going to blow up. So you have to really be careful on what you're doing. So we've gone along the lines of containment for now, working toward extinguishment, some other things on that, but mainly the containment. What I want you to take away from this is, what do you have? What do you have to address this? Some kind of containment thing. The other thing they all come with, because if you're going to handle these things, you got to have gloves. You got to have some kind of protection, because they're bloody hot. They're bloody hot. How about a little bit on protection? I'm scaring you with all these gases that are escaping and all that. So what do? The good news is, on your aircraft, you're changing that air. It's not going to just fill with this and stay like that and hurt everybody. You're going to be dumping that gas. So that's a good thing. Doesn't mean you shouldn't be protected. You've got to protect yourself. So whatever smoke protection that you have on the aircraft, one of the things I say in class all the time, please tell me that whatever smoke protection you have, you can have, well, I'll show you a couple in a second, but the first time that you use that, I don't want that to be in a smoke-filled cabin. Please train on whatever it is you have. You know, some of you have oxygen supplied protect, like the PELS device or oxygen supplied smoke hood. Others have filter units. I don't care. I don't care what you have. Know how the heck to use it. This is just one that I like. It's a firefighting company. It makes the draggers. And some of you may have these. They're pretty basic. You just open it up and pull it out somewhat on this and put it on, right? It's just one of these guys. Pretty basic, protects you very well. Should take you 15 seconds to put on. Wasn't that easy to get out of the package even, right? But anyway, there's that kind. There's the kind that all of you, I think, should have in your briefcase or backpack. It's just a little filter device, right, that protects you a little bit. I don't care what you have. Get something that will protect you and put it on. The protocol, the procedure should be putting that on before it gets bad. So it should be one of the first things. That's why I don't want it to take you 10 minutes to find your smoke protection and put it on. Know where it is, get it on, and then deal with your situation, right? So let's talk about what your job is in this and how to deal with it. And I'm hoping that this will cause you all to have a conversation. We can have some question and answer after this, of course, but also when you get back to your operation, have that plan. If this, then this. If it happens this way, we're going to do it this way. If it happens this way, we're going to do it this way, right? So part of it's awareness, know the risks, know what's on your aircraft and what you're going to do about it. It says prohibit. I don't know about prohibit, but at least understand and control the amount of loose batteries that you have. A lot of people, I have something I'll show you here. This is one of the battery packs that we do a lot of testing with, the standard battery pack. And I've got it open so you can see what's inside. This is a pretty intense battery pack. And this is the most common. I got this off Amazon. It's the most common one out there. The test that you saw, excuse me, that I was showing you a few minutes ago that I had run, it was with 4 batteries. The rest of the tests that we do with this 8 battery pack, there's a lot of energy in this battery. This is about 3 to 4 laptops and 27 cell phones. I don't know, but it's a lot. So you can see from this kind of the progression. If this battery goes bad, then it heats up and goes bad. Well, what does that have to do with this battery? Nothing right now, but pretty soon it will, because it's going to propagate from here. It's going to start heating this guy up, and this guy's going to go, and then this guy's going to go. And sometimes that, like one of the kind of the larger explosions that you saw, was they were heating up together and they went as one unit. So you just never know. Just never know. So anyway, I'm not saying, you have to kind of just know what you have on the aircraft, know what people are carrying, and talk about the procedures. So here are the official procedures, and I'm certainly open to talk about these and have some questions on this. If you've got an overheated device, and there are official recommendations from the FAA on this that I will talk about and go through, and that's what you are supposed to do. And we'll talk about how that is changing. So you are technically not supposed to attempt to move an overheated device. An overheated device is one that is considered actively in thermal runaway. I agree with that. If it's on fire, I don't want you just reaching out and grabbing it. You do want to move people away from the area. Of course, there needs to be a notification process. I imagine if this is happening in the back of the airplane, pilots are going to want to know up front, because that airplane is probably going to start heading for the ground. If you have an active thermal runaway event, you need to know. So here is the official FAA guidance for this. If there's active flame, you use the halon to extinguish the flame. And it will do it. If that, that little picture there, if that laptop, if there's flame on that and you hit that with halon, it's going to take the flame out. That's what you want to do first. Okay. Second is now you want to try to cool it. Water bottle, shampoo bottle of aqueous stuff, whatever it is, you're going to cool it. More than you think you should. You're going to be dumping water or stuff all over because it takes a while to cool it. You don't want to cover it. You don't want to smother it because it doesn't work. You can't just put a blanket over it like you can put a, a wet blanket over a stovetop fire and it will put it out, right? That doesn't work with thermal runaway. It just simply hides it and it keeps doing its thing. So it just kind of insulates the cells and they just keep going. So once you douse the heck out of it until it's where you think it's done, you do that for 15 minutes, and then you consider putting it in a containment bag. Now, that's the official procedure. Let's talk about the what ifs a little bit. What if somebody says, hey, my laptop's kind of hot and it feels like really weird, and you look at it and nothing, it's no smoke, no fire, but it's super hot. Maybe it's bulging a little bit. You never know, but it's super hot. What you do there is taking place before this particular version of the protocol, because it's called at this point that I got the FAA to agree with me on this one. Ben at the FAA said I'm okay with this. It's considered a suspect device at that point. It's not in thermal runaway. Could it get there? Sure. So this is a time that you need to consider what your options are. This would be the time that if you have some kind of containment device, you might consider doing it at that point. Now understand what that does. Will it stop the thermal runaway? No. Now, if it's going to go, and it may not go, you never know. Sometimes they just get hot, they bulge a little bit, and that's it. Never know. If it goes, you'll know. You'll know. It'll start smoke. Sometimes fire, depends on what's going on. But by placing it in some kind of a containment device, you are virtually guaranteed that it's not going to get any worse. Doesn't stop the gases. Should contain the fire. That's the whole point. But the gases, it has to vent. It's still going to go. So you still need to take some precautions. But my concern is protecting the aircraft at that point. So that's why you can consider for a suspect device. And that's where the discussion needs to be in your department about what you're going to do and when you're going to do it. Like I said, there's always questions on this, and we'll talk about that in just a second here. I know that we want to, I'm almost wrapping this up and we'll get to questions. Sorry. I could go for hours on this. I apologize. The last thing on fighting it, I kind of talked about this already, but you do have those two weapons right there, the halon or halon derivatives, good for most things. Some of you will have that funky looking squirt gun water extinguisher. Excuse me. I see a few of those still out there. Those are fine. The yellow one is just this kind of stuff. It's an aqueous based thing and an extinguisher, or just a big old bottle of water. Don't underestimate the value of that bottle of water. Please protect yourself if you're going to have to attempt to fight that fire that's open and it's venting. Remember what I said about the temperatures. These are bloody hot. So gloves, get your gloves on, and these things will protect you very well, right? And hopefully you have your smoke hood on as well. And I feel pretty good about how protected you are. All right, the takeaways from this, and we'll get to questions. I want you to have a plan. Have a plan ahead of time. It's not just talking about it. I do think you need to train on that plan a little bit. And I think the best way to do that is you got a couple pilots sitting up front, you maybe have a cabin crew in the back, and you come together and say, here's what it is. I've got the flight bag on the flight deck that has gone into thermal runaway. What are we going to do? I watched a I watched an actual video of this one time where the pilot had this happen, and he had it in just a canvas bag, and it lit and it started to go. He just grabbed it and hucked it into the back, made the flight attendant deal with it. There you go. All right. Who knows? But anyway, have that plan, train on the plan. If this happens, we're going to do this, then this, then this. I want you to have an awareness and a vigilance about that says, look, always be understanding what's on my aircraft and what can go wrong with it, and just be expecting that. And the last one is kind of a weird one. I realize I said it up front too. I want you to be aggressive. When it comes to firefighting on an aircraft, you have to be aggressive. I don't teach it this way. If I teach little old ladies in community centers and talk about they have a kitchen fire, I do not teach aggression. I teach get the heck out. But for you, you've got to be aggressive. You need to mitigate this risk. You've got to deal with it right now and be aggressive in how you fight it, whatever that is. I can't give you the answer. It just depends on what happens on that aircraft, right? I just don't know. Okay, that's it for the presentation. 46. Hey, they wanted me to go 45. Look at that. That wasn't bad. I'm going to cue that down and go over to here. And there we go. I think I'm back.
Perfect. Thank you so much, Brian. We really appreciate your presentation. So now going into the questions, if anyone has any, please don't forget to put it into the chat box and we will work on answering those. But we do already have a couple questions that have been sent in, Brian. And the first one is, are there certain chargers, maybe off-brand, that induce a runaway on a device or a laptop? Of the known runaways, has this ever been a factor?
That's a good question. So the chargers themselves, I mean, it's an easy one to say. It's all about the manufacturing process. And if you buy a name brand charger, the quality control is pretty good. It's just as easy to get something off the shopping sites that are super inexpensive, and maybe the quality control is not as good. And so there's a little higher risk with that. It's not 100% only that, but I'll tell you this. I said earlier that they don't have to be plugged in to go into Runaway. 100% true. If they are plugged in, yes, the odds are higher because you have energy to the device, and the odds are higher that it will go into thermal runaway. So I wouldn't say that I can with 100% assurity say that a specific type of charger is good or bad, other than just the quality control and manufacturer. I trust an Apple charger more than I do, one of the off brands like that. So, and it would also lead to the vigilance part of this. If your passengers have a lot of things plugged in, the danger is a little higher. Not appreciably. It's fine to plug things in. I'm not saying don't do it, but just be aware that, if you've got a damaged battery and you're applying extra energy to it, even if it's a good charger, doesn't matter. It still could go.
Got it. Our next question here is, do you have any tips for when we travel as passengers to help prevent or mitigate the risk of thermal runaway from occurring?
I assume they mean from their own stuff. If you're packing stuff yourself, I'm taking that's what the question means. If I have my own battery pack and stuff. So the danger that I've seen is the unknown. And when you pack it away, you put it in your purse, your backpack, your briefcase, you don't have control over it. It's not really any more dangerous in a case, but you don't have control over it. So what I do, if I'm carrying, and it's funny, these battery packs, they're still very popular, but they're becoming less popular. And I think one of the reasons is you can plug things in on the aircraft. You plug your phone in, your computer in, straight into the seat, where you don't have to use these as much. But it's having control over these that I think is the important part. The last one, I just actually yesterday I was looking at a couple of last things for the presentation, and I noticed a pretty decent one. Some famous guy, I forget who it was. Anyway, had one of these battery packs in his briefcase under the seat in front of him, and it went off. Again, and by the time it goes off and it's inside something, you're kind of screwed. I mean, you don't have access to it anymore. So my advice is have quick access to your electronics when you're in these situations on an aircraft. If your computer is out and everything is out, then you know you're using it. It gets warm. You can feel that. But more than that, it's just having control. There's not much more you can do.
Got it. Okay. Another question that we had come into the chat was, can you walk us through the first 3 steps you would personally take if you noticed early warning signs?
Okay. So an early warning sign for thermal runaway can be several things. It can be, I think, number one that people think of is the temperature, which is pretty accurate. This thing is sitting on your knee maybe, or your laptop is on your lap, and you feel the temperature. That's one. We actually had one, believe it or not, we had one happen in class a couple weeks ago where the classroom computer actually buckled giving a presentation in a fax class of all places, and it buckled a little bit. It never did light on fire or anything like that, but so it's temperature, it's buckling. If I notice that, I'm immediately calling attention to it. And if it were me and I had the option, I would put it in a containment bag right then, because then at least I know I've got it under control. If you don't have a containment bag, then I'm going to try to move it to an area where nothing else is going to catch on fire. Maybe that's a sink, maybe that's in the ice bucket or the garbage or something but I still need access to it. I don't want to lock it away. I need access to it so I can douse it if necessary. But that's the beauty of this. If you can recognize it early, you may not be able to stop it. The TR is going to happen if it's going to happen. I think the only way to prevent it at that point is if you dumped it in a garbage can full of water, right? And that's just not always an option. So I wouldn't necessarily, excuse me, I wouldn't necessarily just dump water on it if it gets a little bit heated. But my best advice on that is I want to get it to an area where I can contain it. I don't want to put it in the lab or in the baggage out of the way. And that's a consideration. People say, well, I want to get it out of the way because if the smoke comes, I don't want the smoke to be in the cabin. No. Yeah, I get it. Smoke's going to come, but I would rather contain that exothermic reaction, that temperature. Those, like I said, they're hot.
Got it. Another question we had was going back to the batteries, and it was, do batteries have a life or a cycle limit before replacement to prevent this from even happening in the first place?
Yeah, it's a good question. And the answer is not a good one for me. Batteries do have a life cycle on them, but you guys have all had laptops and phones where the battery starts to wear, where it doesn't hold a charge very long. That doesn't mean that the energy still there, but the energy gets spent quicker after you charge them a bunch of times. I don't know the true life cycle, if I'm being honest, of what the batteries are. It's normally several years before you have to replace them, but I'm not really sure if there's an actual cycle on themselves when you have to replace them. I think certain things I know. Well, I'll say this: things like we sell AEDs, and AEDs have lithium batteries in them, and those have a life cycle of, I think it's 5 years on those, if I remember correctly, but I don't know the answer. Let me share one last thing about the battery thing. We're at a place now in the batteries where it's about at its worst with the number of batteries out there, the type of technology. Lithium hasn't changed a ton in a while. These batteries are kind of the same that they've been for a while. They're working feverishly on the battery tech, and it will change. My prediction, you can say you heard it here first, that they're going to make the batteries safe. At some point, they're going to make the batteries so they can't burn. I don't know how close we are. A year? 7 years? I don't know. But it's getting there. It's getting there where the battery tech itself is going to change enough where they're going to be safer. Right now, we're not there. There's a lot of energy packed into that little, what looks to be a AA cell, right? It's about the size of an oversized AA cell. There's a ton of energy in that thing. So there you go.
Got it. No, we greatly appreciate any insight you have on that. Another one we have here is how can we improve communication among team members when dealing with thermal runaway risks? And then also to tie into that, how can we help train pilots when they're in safety training and whatnot to help mitigate the risk during the time of an incident like this if it should occur?
So I love that question. So the communication is kind of what we are all about at Air Care and FACS training. We talk a lot about CRM and how you communicate this. It goes back to my plan thing, right? Of having the plan. It's the what ifs that I think are very valuable when these pilots and cabin crew get together and talk about this. What happens when this happens? And it's that known quantity, that training component. And you don't have to, I mean, you should do this in training. If you go to either pilot or cabin crew emergency procedures training, it's always a component. The pilots, I think, get this a little bit also in their emergency training when they're doing the flight training as well. But the communication part is the one that's missing, and I think that happens in each department. And it's as simple as, like I was saying, just having that plan before, and letting them know, look, pilot to flight attendant, look, if there's an issue in the back, if somebody has a laptop that's hot, I need to know about it right away. And then there's going to be a little meeting about this. And what are we going to do? And again, have that plan in place to do it. There's no one right answer to it. There's so many what ifs that if it goes off right away and it starts smoking and fire, the person in the back, if there's a cabin crew in the back, they're not going to have a lot of time to go up and have a committee meeting with the pilots. They may just be yelling for some help, and they're going to have to deal with it at that point. The pilots have to fly the airplane. If there's a lithium issue on the flight deck from one of the pads or a computer, don't have a lot of time to deal with it right then. That's why that getting everything done ahead of time. Know your containment devices. Pilots are going to know immediately, put on a mask to protect. All of that's going to come with it. But I cannot emphasize enough the meeting of the minds that has to occur, the communication that has to occur. And we say, I'd like to see you do it on your pre-flight meeting. If you're sitting around, here's our flight plan for the day. The limos are going to meet us here, and this is all happening. Part of that should be a couple of what ifs. What if somebody has a laptop that goes? What are we going to do? Where are we going to put it? Are we going to store it? Are we going to fight the fire? What do we have to fight the fire? What are our protection devices? That's the thing that I think that's important.
Got it. Okay. And then one last final question we have is how can we brief passengers to be cautious while bringing devices on board that have lithium batteries and make sure they can recognize signs of a runaway quickly if the crew is not close by?
Boy, that's a tough one, right? Nobody wants to talk about it with the passengers. But the good news is passengers always listen to you, and they always do what you say, right? Maybe not. The thing about passengers is you have to assume that they've got 17 batteries and a whole bunch of extra things that they shouldn't necessarily have, right? It's a tough one. Again, in the real world, it's tough to go back especially on a charter flight and say, by the way, everything we do up here is super dangerous and all your batteries are probably going to kill you, so we should not have them. You can't do that, right? So I think your ability to understand what your passengers have just from the customer service aspect of it, say, okay, gosh, if you're charging your laptop, let's make sure that your laptop is charging out here on the table or whatever it is, so it's accessible. I would prefer not charging the laptop, which a lot of them do, by running a cord into the case and charging them that way. There are a few things you can do to raise awareness, but I'm realistic enough to know that you're not going to make everybody show all their batteries when they get on the airplane and that kind of thing. It's just not realistic, right? The people that you have over and over again, if you're doing a lot of 91 flights and you get the same passengers, they can learn. You can kind of help them learn about the risks a little bit and just say, we just want to make sure that these things are accessible so we know where they are, perfectly safe. I mean, you look at the number of incidents that have occurred, there's a decent number of incidents, but come on, the number of batteries that are out there, it's generally generally pretty safe. It's just when it happens, it can be quite dangerous. So I want to be aware that I just don't want you to be so scared, and the passengers so scared that they don't do anything. It's just educating them a little bit on, hey, that laptop, let's just make sure that thing stays out while we're charging it. And I don't want to put a lot of loose batteries in the baggage. I want my big backpack to go in the baggage compartment, and it's got 17 loose batteries. Nah, I just as soon not do that. I just soon have access to that stuff. Because the devil is better, right, than that one. Because if 17 batteries go off in the baggage compartment, you got issues, and you're going to have a hard time fighting it. So I'm not sure that was a great answer to it, but it's truly just trying to get an awareness. And I really want, more than anything else, I want the crew aware of what's there and have that plan.
Sure. Yeah, no, that makes complete sense. And with that, I'm looking to wrap up here. That was kind of our last question we had. From here, I would like to thank you, Brian, for the awesome presentation today. It was very descriptive and very in detail, and I think that's really a big game changer coming in aviation here, and with the step of these types of batteries and the Runaway and stuff. And thank you again for presenting on behalf of the safety committee. And afterwards here, I'd like to let everyone know we do have a safety day coming up here in April 9th at 10 a.m. at Atlantic Aviation up at the Chicago Executive Airport. And after that, thank you very much for your time, and thank you everyone for joining in today.
Thanks. I appreciate the opportunity to do this, you guys, and know that we've got our training center out at DuPage now too, and we're there all the time. So, and if you have any questions, by the way, after this that you want to come straight to me, Brian at Aircare, I'm happy to answer any questions. Shoot me an email or a phone call. You can always get me through Beth, our training center manager at DuPage as well.
Perfect. Thank you very much. We'll make sure to have that listed, so if anyone does have questions, they can reach out afterwards. So have a great day, everyone.
Thanks, everybody.